Welcome back to Chem with Kess. So today we're talking about cleavage of cis diols. So earlier we talked about the formation of them. I tried to put the videos in order so that way it kind of makes sense in the flow. We have the direct way to add the cis diols, which was using the Ozzy Osbourne has 4 kids or the KMNO4 under basic conditions, so go back and review that video. And the indirect way is also when you create the direct way creates cis diols. And the indirect way, you have to go through an epoxide and then you open the epoxide. When you do this, then you're going to get a trans diol. So this reaction works on both cis and trans diols. So imagine before this beautiful picture that's drawn before you, there was an alkene present between here. Why do I know to focus on this area? Because not only do I have the cis alcohols, this alcohol over here is lonesome. So if you see anything that's cis, it would have to be right next to each other. Now, on top of that, this reaction also does not require that the diols be cis or trans. It can work if it were planar as well, which means flat. So what's going to happen in this reaction is the expectation of between the two carbons where the diols are, we're going to cleave, which means this reaction is going to separate. The reagents used are normally, once you see this IO4, just know that's going to be the one that causes you to cleave your diols. It can have a hydrogen in front, an Na, and it's normally over water. Come up with cute acronyms. I want to hear some cute acronym names that you come up with. Drop them in the comments below, and let's get creative. Maybe the best one should win something. I'll talk about that later. So for this one, when we do the cleavage, that means I'm expecting, let's go back into black pen. When you're doing the cleavage, we are expecting the left side to, at that carbon, change, and at the other carbon change. So I like to just draw the framework of the picture first, because that way you'll panic less, okay? So trust me. So less panic. Both of these reactions work the exact same way, so it wasn't really necessary for me to draw them both. This reaction in the products does not give you any type of stereochemistry, so that's not to worry about either. So for this one right here, where the OH was, you will create a carbonyl in its place. So same thing for over here. All you're doing is creating a carbonyl in its place. So when we do this cleavage reaction, that's really what's going on here. Now, it would make sense because here we would have a hydrogen here and a hydrogen here. Let's say it wasn't a hydrogen. Let's say I changed it up like live action here. Let's say I changed that to just a regular methyl group. The same idea would go. I'm just expecting, that was just drawn awkwardly. Fix that for y'all. So here you would still have your carbonyl at the point of where it was, but you would just have whatever 2 groups are remaining. So in this case, just really pay attention to what was given at the beginning to make sure you transfer all of your groups attached to the carbon appropriately. Since I just changed the problem, it's going to bother me not to fix this one here in live. So that would be your answer for how you go about thinking of the cleavage of cis diols.